All right, hey everyone. So for today, what we're going to do is we're going to do a quick lab on making a graph and sort of analyzing that data very quickly using spreadsheets like Google Sheets. Microsoft Excel works very much the same way, but you guys are all on Chromebook, so we're going to go with this. For this lab, you're just going to make the graphs. You're going to make a total of 5 graphs. 3 of them I'm going to help you along with using this video. The 4th and 5th one you're going to do on your own. For each graph, you're just going to make it the way I'm going to show you, and then just copy and paste it right into here as though this were your lab report. So to make the graphs, each of our data sets are in here, and you're going to graph each of these. So first graph, second graph, third graph, fourth graph, fifth graph. If you make all those graphs, that's it. I think you guys will see why this is helpful pretty quickly, because normally to make the graph, you have to plot each data point by hand, you have to draw a line of best fit by hand, you have to calculate the slope by hand. What we're going to do is we're going to have the computer do all of that for us, which is nice. So let's start with this data set. We've plotted mass versus force. As we learn more topics, we get more equations, and we sort of learn new concepts. We'll talk about why we're going to graph like one thing versus another, why the slope is helpful, like why we even care about this. But for now, I'm just going to tell you that this goes on the x-axis, this goes on the y-axis. So we're graphing mass on the x and force on the y. So to make our graph, what we're going to do is, first step is highlight all the information we want to graph. So we're going to start here, and I'm just going to highlight everything. So it'll all turn kind of bluish. You can catch these the headings for each data column. That's fine. It'll label your axes for you, which is nice. One less thing to do. Next up, I'll do this a little bit slowly here. We're going to hit Insert, Chart. And for this class, we're always, more or less always going to do a scatter chart, which Google Sheets guesses what you want to do, so it has like, the suggested charts. Again, we're going to go for the scatter. If it didn't do scatter, you would have to scroll down and select it, because it tries to guess if you wanted to make like a pie chart out of this information or what have you, or a map out of it. Again, we're almost always going to do this scatter option, which it mostly defaults to anyway, but it's worth pointing out. And look how much work it did for us. It plotted all the points. We've got the mass on the x-axis, just like I wanted, and the force on the y-axis. The reason it worked out like that is Google Sheets sort of defaults to x in the first column, y in the second column. So by arranging it, so your x-axis values were first, we were able to, basically make it, create the graph the way we wanted it to. Which is cool, but I did say that we want a line of best fit and a slope to go with it, because that slope has significance. In this example, the slope represents the acceleration of the object. The acceleration of an object of a certain mass undergoing a bunch of different forces. So what I'm going to do is, I'm just going to double click back on this graph so that my options show up. And what we really want to do here is, again, to add that line of best fit, go to Customize, Series, and then scroll down a little bit, and we're just going to add the trend line, which is just the word they use for line of best fit. Cool, I noticed that line popped up. The line of best fit, the rule of thumb is it has about as many points above it as it does below it, which this one kind of does. So nice, that's all done for us. And lastly, I'm really interested in the slope, so what I'm going to do is, to add that slope, we just scroll down a little bit to where it says Label, and we use the equation. And that's it. All done. The equation for this line is 2.13x plus negative 0.485. The slope is the 2.13, and the reason for that is it's presented in y equals mx plus b format. So you should remember that m, the slope, is the one that's multiplied by the x. And that's it. And since I told you already that the slope is the acceleration, that's what this number means. It's the object's acceleration, 2.13 meters per second squared. And that's it. You can play around with this. You can do other stuff. You can change like the line color, the dots from circles to, I don't know, whatever. But I don't really care about any of that. I'm more interested in the physics. So, any time that you spend making the dots look pretty is not time that I'm looking for. I don't really care. As long as your axes are labeled with units, your graph is titled, and the physics looks good, that's it. To copy and paste this in your lab report, we're going to click these 3 dots up here. We're going to copy the chart, go back to our lab report, and we're just going to paste it. Either Control V or right click, paste. It gives you an option here to do one or the other. I'm going to do unlinked. Linked just means that if you make changes here to your data, it'll automatically change in this lab report, which is nice if you're like not sure you did it right, but you kind of want to do your work ahead. But for us, you know, again, we know we did it right because we followed along, and that's it. And one of the things that's nice about this is once it's here, it's like in your lab report. So you can be like talking about it, like I did some stuff, and now here's a graph, and it's just right in the lab report. It's got a nice flow to it. Everything's there, and it looks nice. But for today, we're just going to paste the labs in, and that is it. All right, graph number 2. So for this one, we've got a data set. We're graphing displacement versus time. This one, I want you to try it on your own, and then if you get stuck, play the video, and the video is going to go through it. You know you did it correctly if the velocity, which is the slope of the graph, is 3.25. So if you get a slope of 3.25, you did this right. So pause this, try it on your own. If you're looking for that second graph, it's back in this spreadsheet, and just click here, graph 2. Pause it, try it on your own. If you have trouble, then hit play. All right, I'm hoping you use that chance to, as an opportunity to try this on your own. So here's what we're going to do. We're in X then Y, meaning X is in the first column, Y is in the second. So we're basically all set to just highlight our data. Insert. Chart. We're already in a scatter chart, so we're good. But again, if it wasn't, we could click here and find it. And we're almost there. I like the axes titles. I like the graph title. So we just hit Customize, Series, Trend Line. And we're generally speaking always interested in the trend line because it often represents something physically significant. In this one, the slope of the line represents velocity. If you remember from our DVA, the slope of this displacement graph is the velocity of the object. But we don't have the equation yet, so we got to scroll down a little bit. Label equation. Awesome. Y equals mx plus b. The y-intercept is almost 0, which is why it's this tiny number, 0.22. And then 3.25 is the slope, 3.25 meters per second, y over x. And that's it. For today's activity, I'd like you to just copy the chart, paste it in, Control V, and again, I'm just going to do unlinked for today. It's just less going on. Cool. Graph 3, this one I do want you to follow along. So for graph number 3, we're just going to go again, back to our charts. I'm going to hit this right here. Okay. Now, here's something a little different here. We've got our x-axis, but the y-axis isn't directly next to it. We have this other sort of erroneous data set in the way. So how do we graph this column versus this column? Well, there's a couple things you can do. You can copy and paste the x column here, and then the y column here. That way it's in like x then y form. But let's actually just learn how to do it. So to make our graph, as long as we have our x-axis in the first column, I'm just going to highlight all of this information. This is not the final data set I want graphed, but let's just make the graph and then we'll worry about fixing that. So to make the graph, insert, chart. All right, now for whatever reason, Google Sheets thought I wanted to make a line graph, which we don't here. I want to make a scatter graph again. So, again, it's none of the suggested ones. Google Sheets is a little miffed at what I'm trying to do. So I'm just going to scroll down to the scatter. Cool, awesome. So we've got displacement for time. It looks like it's curved, which means the object is accelerating. But here's the problem again. I don't want to graph displacement versus time because I told you in this sheet that I wanted it to be time on the x and velocity on the y. So here's what I'll do. Double click on the graph so that my options show up. And the x-axis is time. So I like that. I'm going to leave all of this here. But the series is the y-axis data set, and I don't want it to be displacement. I want it to be column C, the average velocity. So what I'm going to do is I'm just going to click on it. I'm going to click this window, which lets you select whatever you want. Select data range. So I'm going to highlight all the things I want to graph on the y-axis. And I'm just going to hit OK. Cool, awesome. Notice how the scale changed completely because we're only going up to 15 as opposed to the 150. So it kind of fixed all the numbers for us. It did almost everything we wanted to do, but it didn't really fix our labels here. Right? This isn't displacement anymore. We changed it to velocity. So I'm just going to change it to velocity, measured in meters per second. I'm going to change the title of the graph to velocity, which is again meters per second. Other than that, we're good, right? So again, to change the data set, what we did was we went to, under Setup, where it says Series, we just clicked on it. We used this window to select the one that we wanted, which was this one right here. Cool. As always, though, again, for this activity, we're going to do the line of best fit. We're going to find its slope, because the slope of a velocity graph is the acceleration. It's a meaningful value with significance. So, customize, series, trend line, label, equation, awesome. That 1.48, that's the acceleration measured in meters per second, or meters per second squared. So for today's activity, just copy the chart, paste it here, and that's that. Okay, I'm looking for you to make 2 more graphs out of sheet 4 and 5. I think sheet 4 is like sheet 4 is just a straightforward do this on your own type of thing. Sheet 5, I mixed in a few different things. We're graphing column A versus column C, and I'm asking you to do the calculations for column C. Remember the last time we did a lab with these sheets? We did equals, and then you typed in an equation to do what you wanted to. So see if you can think of an equation to solve for the velocity that involves displacement and time. If you get stuck on any of these, go in the Google Meet and just ask me. I'm happy to help you out with it. And that's it.